Dear students, in this lecture video, we will have a brief introduction about digital sensors, and we will see how transmitted energy from the transmitting sensor and the received energy or power from the receiving sensor determines the range of communication between the two. Here is the outline. We'll discuss about analog and digital sensors, mechanical switches, optical sensors, optical proximity sensors, inverse square law, and digital cellular telephones. Okay, sensors. Sensors form the front end of information systems. A sensor is a device that converts the physical energy or physical phenomenon into an electrical signal. A sensor is an information source. By sensing the physical phenomenon or the physical energy, we will get an information. So it is an information source. It provides information in terms of analog or numerical or digital form. Attached to a sensor, there is an information processing system. This information processing system interprets the data supplied by the sensor. For example, some examples of sensors. Mechanical switches. These are simple sensors. They produce a binary output. For example, when a switch is open, we have 0, and when a switch is closed, we have 1. So the information is 0 when the switch is open, and the information is 1 when the switch is closed. And sensors that are important in scanning and data communication systems. They use electromagnetic waves or light energy. For example, sensors in remote control systems. For example, in our television, we have a remote control. They use infrared light. And other sensors, optical laser scanning systems that read barcodes. And in cellular communication, for example, a mobile phone by itself is a sensor. Why? Because it senses the transmitted data, and through the antenna it receives the signal, and by that way we get the transmitted information, which can be an audio signal or a video signal. So sensors, such sensors transmit or emit the electromagnetic energy, and the receiver detects this energy. Sensors can be analog or they can be digital. Analog sensors produce a continuous analog signal. That means the information received from analog signals is continuous in value. It can be anything. It is continuous in value. For example, mercury thermometer is one example of analog sensor. In a mercury thermometer, it senses the temperature of a body or an object, and the level of the mercury in the tube tells us the value of the temperature. And digital sensors produce discrete types of signals. They produce discrete signals. For example, the simplest case of a digital sensor is a binary sensor. It will produce either binary 1 or binary 0, like the switch we saw it earlier. And other sensors are digital thermometers. Digital thermometers, they produce a digital value which corresponds to the temperature of an object. Analog sensors are more accurate than digital sensors. Why? Because they can have any value. The value is continuous, so it will be more accurate. However, digital sensors are less accurate. Even though they are less accurate, they provide sufficient accuracy for most applications. So nowadays we have a lot of digital sensors. Okay, let's see a mechanical switch. This simple mechanical switch sensor. So what happens when the switch is closed? We have an electric power supply here, and we have a load here. This load can be, for example, a motor, it can be a beeper, it can be a digital clock, or it can be a buzzer, so it can be a heater. So when the switch is closed, then an electric power will be supplied to the load. So current will flow, and for example, if it is a heater, the heater will work. So this is a digital switch, or a digital sensor. So by when it is opening, it is 0. When it's closing, it is 1, for example. Light switches. Light switches are switches used in personal security devices to alarm when a door is opened. So, for example, when the door is opened, then the switch will sense that information and it will trigger an alarm system, which the alarm system, for example, it can be a buzzer. So the buzzer can signal us whether there is an intruder or whether a door is opened or closed. Mercury switches. Mercury switch use a mercury as a conducting fluid metal in order to close and open a circuit. That means there is a mercury between the two contact points. So when the contact point is closed by the mercury fluid, then it will trigger the sensor. That means, for example, a thermostat uses a mercury switch to activate a heater. Keyboard switches. For example, we have a keyboard here, all the rows connected to one wire, all columns connected to another wire. For example, the rows can be connected to positive power supply and the columns can be connected to ground. So when you are pressing a certain key in a keyboard, what will happen? The row will be connected to the column. So there is a power supply, that means. So the switch will be closed. That means when the switch is closed, it will be interpreted by a microcomputer chip, which is attached to that switch in the keyboard. And it will interpret this row to column and connection and transmits the corresponding D character code to the computer. Okay, this is an example when the letter D is pressed. When the letter D is pressed, what will happen? Column 2 connects to row 1 and a microchip in the keyboard interprets this row to column connection and transmits the corresponding D character to the computer. By this way, we can the computer identifies which key is pressed on the keyboard. Okay, in that keyboard key matrix, we have how many switches we have. For example, here I have 5 columns and 3 rows. I will have 5 times 3, which is 15 switches. So any switch matrix having NR rows and NC columns contains NS normally open switches, which is equal to NS is equal to NR times NC. A wire in each row connects to one terminal of all switches in that row, and a wire in each column connects to the other terminal of all switches in that column. And the total number of wires I have is NW equals to NR plus NC, the number of rows plus the number of columns. It's very easy. Now let's see, for example, I have here a standard telephone. A standard telephone has 12 buttons arranged in a switch matrix. So excluding the letters A, B, C, D, we have 3 columns here, okay, excluding the letters, and we have 1, 2, 3, 4 rows. So 4 by 3. 4 by 3 means 12. I have 12 switches, that means. So let's determine the number of wires, smallest number of wires that are used to connect the 12 switches. So how we find? Okay, we have NS. NS means the total number of switches is equal to 12, which is equal to NR times NC. and the total number of wires required is NR plus NC. So this should be minimum. So how? Because we need to minimize the number of wires used to connect the switches. So we should find two numbers whose product is 12. So what are the possible combinations? 1 and 12. So 1 row and 12 column, for example, it will give you product 12, but the number of wires will be 1 plus 12, 13. And if I have two columns and 6 rows, 2 times 6, the product is 12. So 12 switches, but the total number of wires is 8. If I have 3 columns and 4 switches for three columns and 4 rows, I will have, for example, 12, and the total number of wires is 7. So I will select the one with minimum number of wires. So if I see from this, I will have 7. 7 is the minimum number. So I select 3 rows and 4 columns, or 3 columns and 4 rows. That means optical sensors. Okay, what are optical sensors? Optical sensors, they use optical energy, for example, like infrared light, okay, to function. So they transmit infrared light to the transmitter and to the receiver. So the transmitter sends infrared light and the receiver detects the infrared beam. For example, here I have a transmitter sensor and a receiver sensor. When the transmitter transmits the infrared beam, the receiver receives, then the switch can be closed or open depending how we design it. Okay, for example, for this case, the switch was normally open here. It was normally open. Then there is here an object between the transmitter and the receiver. So the infrared beam comes here, but the object blocks the infrared light. So the receiver is not detecting the light. So the switch will be closed. Okay. So this is called a beam interrupt sensor. The transmitter directs the infrared light beam into the receiver. The receiver produces an output signal based on the presence and the absence of the object in between the transmitter and the receiver. So for what applications we can use this? For example, this can be used for counting objects, for counting pills in pharmaceutical industries, for example. So the counter will detect whether there is object between the transmitter and the receiver sensor. For detecting intruders, for example, if there is an intruder in between the transmitter and the receiver, then the switch will be closed. And this, when the switch is closed, it will trigger an alarm system, which can be a buzzer. By that way, we know whether there is an intruder or not. Okay, what is important in the design of sensors is threshold. Threshold level means the minimum received signal by the receiver. Okay, we have the transmitter sensor and the receiver sensor. So the receiver should be designed based on a minimum received power level. Okay, that minimum received power level, which makes the receiver to function, is called the threshold level. So sensors produce output according to a predefined threshold level. For example, a binary accelerometer that inflates a bug depending on the amount of car shock. That means if there is, depending on the magnitude of the shock, then it will inflate a bug. Binary data transmission. When a sensor transmits a binary data, it will be affected by a noise. So the received signal will be like this. For example, it will be fluctuating. Even though you are transmitting binary one means, for example, here there is a signal, and binary 0 means there is no the signal. It looks like noisy signal like this. The receiver will receive this signal. So we need to be able to have a threshold level. That's why threshold level is important for the design of the sensors. Optical proximity sensors. Okay. What are optical sensors? They use optical light, for example, infrared beam for detecting objects. Okay. An optical proximity sensor is a sensor which has the transmitter and the receiver in the same location. That's why it's called optical proximity sensor. For example, barcode scanners. Barcode scanners in supermarkets or any groceries, the transmitter and the receiver is located in the same location, okay? So the transmitter will send a beam of light again, then here is the object, and based on this object, there will be a reflection. If there is a reflection, that means the switch will be closed. And that means if the switch is closed, then there is object. So by this way, it will detect the object. And in the case of barcode, it will detect the barcodes as we see in the next slide here. One of the optical proximity sensors is the one used for universal product code scanners. Here, this is a barcode. For each barcode, we have a corresponding ID identification. Okay, so how is this ID generated? How is this identification is generated? By using the sensors. So the optical proximity sensor sends light to the barcodes, and it will generate a signal based on the reflection from the barcode. You see here the barcode has dark and white stripes here, dark and white stripes. So the digits are encoded with white and black bars corresponding to the regions of high and low light reflections. For example, the white part is high light reflection and the dark part or the black part is low light reflection. Based on this, a unique waveform is generated, and that unique waveform will have a unique identification number. For that identification number, for example, in supermarkets, there will be a corresponding price tag for each item. So this can be used for retrieving the price for that item, the item we buy from the market, that means. This is called standard UPC symbol scanner, Universal Product Code scanner. So here is, for example, if the light passes here, okay, beam of light passes to the item, these are the barcodes. Based on that, a binary sequence is generated. For example, for the dark one, for the light part, 0 and so on. For the dark one, and here I have 0, 0, 0 because there is a lot of white part here. So this sequence is sequence will have a unique number. So each item will have a unique ID. That means identification. Of course, the duration of the wave depends how we scan it. For example, if we scan it like this, I will have a shorter wave, and if I scan it here at an angle, and I will have longer waves. Okay, that's all about optical sensors here. In the next video, we will see how the transmitted energy or the transmitted power from the sensor and the received power from the sensors determines the sensitivity of the receiver, the sensitivity of the receiver. So the transmitted power from the sensor and the received power from the sensor are very important factors for detection. Thank you for listening to this lecture.